Hey, good people, Arthur Morris here. Hope all is well. In this video, we have another type of special multiplication, which is squaring a binomial univariate. So we have a formula for this type of problem as well. Now, before we get into the formula, I want you to understand, since that is squared, that is the same thing as 4 plus 7w times 4 plus 7w. So if you happen to forget the shortcut for some reason, then you just expand that out and then use the full distributive property as we have before. But the shortcut for a binomial squared says if we have a binomial squared, then the pattern or the formula for that is the first term squared to multiply it out plus 2 times AB, 2 times the terms, plus the last number squared or variable squared. First variable squared or first number squared times 2 times each number or variable, whatever's there, plus the last number or variable squared. Now you will also see a special for subtraction. And the only thing that changes is the sign on the second term. Like so. All right, so knowing this formula keeps us from having to multiply this all the way out using the full distributive property. So for this particular problem here, if we're looking at the formula, the 4, based on the formula, the 4 is in the place of A based on the formula, and the 7W is in the place of B. So to multiply this out, I know I have the first term squared plus always 2 times each one of those terms, and you don't have to look at the signs in there when you use the formula, plus the last term squared. Right? So 4 squared plus 2 times 4 times 7w plus 7w squared. And that's based on this formula right there. So 16 plus, what do we have? 8 times 7, 56w plus 7w squared. Square each one of those, so 49w squared. And you can leave your answer like that. We would normally write it in descending variable order. But either answer would be okay. Will be okay. Either one of those. I just changed the order because we normally write answers or expressions in descending variable order if we can. We only have one variable. Okay. So again, the alternative to this is to use the full distributive property: 4 times 4, 4 times 7w, 7w times 4, 7w times 7w, and you will end up with the same answer. All right, so let's try another one. All right, so we're going to use our formula. A plus b squared equals the first term squared, or first term or number squared, plus 2 times ab plus b squared. And in this case, w is in the place of a and 3 is in the place of b, based on our formula. So again, the first term squared plus 2 times the terms. So 2 times w times 3. And again, you don't have to worry about the signs. The signs are taken care of in the formula. Plus the last term squared, or 3 squared. So w squared plus 6w plus 9. And it takes practice, so just make sure you practice. The alternative to that would be to write out w plus 3 times w plus 3 and multiply it out like we've done before. And you see you get the exact same answer. Alrighty, let's try one more. Alright, so here we have a minus 5 minus 3y squared. So we're going to use the same pattern except the sign on the second term is subtraction. So we have a squared minus 2ab plus b squared. So the first term squared minus 2 times the terms plus b squared. And again, you don't have, once you're filling in the formula, don't worry about the signs. The signs have been taken care of with the formula if you're using that. So 5 is in the place of a and 3y is in the place of b. Not concerned with that minus there because it's taken care of in the formula. So 5 squared minus 2 times 5 times 3y plus 3y squared. First term squared minus 2 times the term in the numbers plus the last term squared. Again, if you're using this, the signs are taking care of the numbers. So in this case, 5 is in the place of a and 3y is in the place of b from the formula. Alrighty, so multiply it out, 25. And then 2 times 5 is 10, times 3 is 30. And then 3y squared, so 3 squared is 9, y squared. And again, for these problems, you can leave it like that. That will be fine. If you want to write in descending variable order, that's great as well. Alrighty, good people. Hope you found this video to be helpful. I will see you on the next one.